Okay, so in this video we're going to talk about solving quadratics by factoring. The degree for a quadratic function is 2. We haven't really talked about how you find that degree, but it comes from the fact that all of these problems have an exponent of 2. So that's why it's a degree 2. This basically means that there are up to 2 solutions. There could be less than 2 solutions, but 2 solutions is the max that we'll have. The solutions of a quadratic are also called x-intercepts. That's going to be the main one we focus on today. Zeros or roots. So all of those words are interchangeable when we say solutions. A quick basic warm-up to focus on the big idea of today's lesson is we're going to evaluate a pretty simple arithmetic problem. So we are multiplying the pair of numbers that are in each parenthesis, but it might make more sense to first add the common terms on the inside. So we get 50 inside that first parenthesis and we get 0 inside the second. So it really doesn't matter what this number right here is going to be. It could be 50, it could be 50 billion, because ultimately we're multiplying it by 0. We're going to end up with an answer. So the zero product property just says if just one of 2 factors is equal to 0, then the entire expression is equal to 0. Said another way, algebraically, this expression x minus a times x minus b, which you'll notice is kind of the format of a lot of our answers, that whole expression is equal to 0 if either one of the individual factors is equal to 0. So we're going to talk about the steps to solve a quadratic equation by factoring. If you can factor, then that's the hard part of these problems. So the first 2 steps to solving are pretty familiar. First one is set the entire expression equal to 0. So we've been doing that for a while. Factor completely. So that's what we've been working on in class a lot. Step 3 is the new step, but really this you'll see is mostly just a pre-algebra step. It's pretty simple. So let's look at one example together and you'll try one on your own. So the first thing we need to do is this expression is not equal to 0. So before we think about solving for x, I'm going to subtract 2x from both sides. Typically I want to try to keep that a coefficient positive. So that's why I'm moving everything over to the left-hand side in this problem. And I'm also going to add 10 to its like term. So the right side cancels out and we get 0. And the left side becomes 2x squared plus 5x minus 3. So now we need to factor this. So there's no greatest common factor, but I notice the a value is greater than 1. So I'm going to do jump, slip, slide, or I've seen some of you do grouping method on your papers. That works as well. I need 2 numbers that multiply together to give me -6, that add together to give us 5. So in this problem, it's going to be 6 minus 1. 6 minus 1 is 5. 6 times -1 is 6. I don't expect you to come up with them that quick, but just make sure you understand the process on how to do that. All right, so now we factored it. Now comes kind of the weird step, is we're going to take that original a value and divide these terms by 2. So x plus 6 divided by 2 is x plus 3. And then this other factor becomes 2x minus 1. So really everything up to this point is review. Our last step is we're trying to make this equation true. So we know that if either one of these factors is equal to 0, then the whole expression is going to be equal to 0 by the zero product property. So what I'm going to do to get my solutions, I'm going to set each individual factor, starting with x plus 3, and solve it for x. And again, pretty simple process here. Just subtract 3 from both sides. One of your solutions should be x equals -3. The other factor is 2x minus 1 equals 0. This one, there's one extra step. And here is our other solution. So 1/2 and -3 are two solutions. Checking your solution is optional, but recommended. So I'm just substituting my original x value in for x in both places there. And we can use a calculator quickly to verify that this does equal 0. And we could do the same thing with 1/2. But instead of 1/2, I'm going to use 0.5. Just because it's easier to put in the calculator. So you see both of those solutions make this original equation true. Part 2 just wants you to realize that the solutions, remember, are also the x-intercepts. So x equals -3. This says just make a quick sketch of the equation's graph. The vertex does not have to be accurate, but make sure it goes through the correct zeros or x-intercepts. So this crosses the x-axis at -3, because again, we just said -3 makes the entire equation equal to 0. So that's why it's right there on the x-axis. And then the other 0 is at +1/2. So I'm going to estimate it there. And for now, I'm just going to sketch a really quick curve. That part doesn't have to be accurate. Just make sure it goes through the right x-intercepts. So the solutions of the problem are the x-intercepts graphically. I would encourage you to pause the video and try the your turn on your own. So I'm going to show the first couple of steps here in just a couple of seconds. So that's what this one should look like right before you factor it. Subtract 2 from both sides. Now factor that using jump, slip, slide. Here's the next couple of steps. There's the next couple of steps. So sometimes we get stumped right here towards the end. Before you slip that 6 to the front, we need to reduce both of these fractions. 4/6 can reduce to 2/3. And 3/6 reduces to -1/2. Then slip that number to the front, so that becomes 3x plus 2. Slip that number to the front, it becomes 2x minus 1. And then finally, we're going to set each individual factor equal to 0 and solve and get our solutions. So there's our solution. So we just have to estimate on the graph +1/2 and -2/3. So this is going to be a really skinny graph, and that makes sense because the A value is 6. So this thing really gets stretched out quite a bit. We're just estimating again in that vertex. We have no idea. Main thing is focused on those x-intercepts. All right, this last problem is for you to try on your own. It's already set equal to 0. Solve it and then enter your answer.